Welcome back, everybody. You know, we love to get into the nitty-gritty, and this time we're diving into some AI research that has me super excited.
Oh, yeah.
Yeah. We're talking about small language models,
Okay.
specifically one called SmolTulu. And get this, it's getting results that are on par with these big, huge AI models that everybody knows, but it's using way fewer parameters,
Interesting.
like under 2 billion. I mean, that's crazy, right?
To help us really dig into this, we've got our AI expert here with us.
Always happy to be here.
So to kick things off, why should we even care about small language models? I mean, is this just about, like saving space on our phones?
Well, I mean, that is part of it,
Okay.
but it's so much bigger than that.
In what way?
Imagine if we had powerful AI that can run on like any device, not just these huge data centers.
Oh, wow.
And think about all the researchers all over the world who maybe don't have, tons of resources.
Right.
They could use and develop AI if we have these smaller models, and that changes who gets to benefit from AI.
Okay, so it's like democratizing AI.
Spreading the smarts around, love
Right.
that. But how do they even make these small models so powerful? What's the secret with this SmolTulu?
Well, they found something really important about how these AIs learn. Specifically, the relationship between something called learning rate and batch size.
Okay, so time to put on our learning caps here.
Yeah?
Can you break down those terms for those of us who aren't AI experts?
Yeah. So think of learning rate as how fast the model learns new information.
Okay.
And batch size is how much information the model processes all at once.
So it takes too big of a bite?
Exactly. If the learning rate is too high or the batch size is too big, then the model just gets confused.
Okay.
But if it's too slow or too small, then it'll take forever to learn.
So it's all about finding that perfect balance.
Yeah, like that Goldilocks zone of learning.
Right, okay, I'm starting to get it. But this is where it gets really interesting, right? Because they didn't just find one perfect balance. They actually found that the best learning rate to batch size ratio depends on what you're trying to teach the model. Exactly. Like different learning styles. Different learning styles for AI.
Yeah.
What?
They found that reasoning tasks like solving a logic puzzle need a higher ratio.
Okay.
It needs to like intensely focus and learn quickly.
Right, you don't want it to be slow when it's trying to solve a puzzle.
Yeah, exactly.
But what about things like pattern recognition? Like figuring out which word goes at the end of a sentence.
Yeah, for those, they found that a lower ratio was actually better.
Really?
Yeah, it's like the model needs to be able to see more to find those patterns in the language.
So it needs like a wider view.
Exactly.
Sorry, I'm following you.
And they actually made visuals for this, like contour maps, that show these different zones of learning for AI.
Wait, so now we have a visual guide for training AI.
Yeah,
That's amazing. But this brings up a really interesting question, right?
absolutely.
If these smaller models need more focused learning to be good at reasoning, does that mean that the bigger models are just using their size instead of being smart? That is a great question. It really makes you wonder what smart even means for AI.
Right. Okay, so my mind is officially blown. But before we get too lost in the theory, can we talk about what tasks they actually had SmolTulu do?
Oh, yeah.
Like, give us some examples so we can picture it.
So for reasoning, they used something called ARC, which is like these multiple choice questions, but they're designed to test how well it can problem solve.
Oh.
And they also had it do GSM-8 Pay, which gives it math problems that are like 8th grade level.
Oh, I don't even know if I could do those.
Yeah, right. And then for pattern recognition,
Yeah.
they used HelloSwag and iFeeble, which are all about understanding sentences and figuring out like which ending makes sense.
Okay.
Really testing if it can understand nuances of language.
Wow, so this is really changing the game then.
Yeah.
We have these small models, and they can be really powerful if we just figure out how to teach them the right way.
Yeah, and they didn't stop there.
Oh.
They took this finely tuned model and they put it through another whole process called direct preference optimization, or DPO. DPO. Like
what?
all years.
So DPO, it's like teaching the model to understand what you prefer.
Okay.
It's all about aligning what the AI does with what we as humans want.
So like teaching it to have good taste.
Yeah, exactly. Like you're saying, hey, SmolTulu, here are some different outputs for this task. Which one do you think humans would like best?
Okay.
And then it learns to predict what we prefer.
But how did they measure that? Is there like some kind of human preference scorecard?
Well, they actually use this technique where they show the model two answers,
Uh-huh.
one that's considered better and one that's considered worse.
Okay.
And it learns to tell the difference.
So it's like showing it good and bad examples so it can figure out the pattern.
Yeah, exactly. It's not about giving specific instructions.
Right.
It's more like showing it examples and letting it learn on its own.
It's like teaching a kid manners by showing them how to behave.
Yeah, exactly. And here's the really interesting part. They found that this DPO process actually made the results from the learning rate and batch size stuff even better.
No way. So the model that had the higher ratio for reasoning tasks, it get even better at reasoning after DPO.
Yes. That model got a score of 67.7% on something called IHEVL, which specifically tests how well a model follows instructions.
Wow, that is impressive. So if we can just figure out the best way to teach these models for each task, we could have some really amazing results.
Exactly.
And what about the model that had the lower ratio for pattern recognition?
That one kept doing well, too.
Oh.
It scored 57.1% on ARC.
So it's like the first training stage really set the stage for what the models were good at,
Yeah.
and then the DPO process just made them even better.
Exactly.
That's pretty awesome. But was there anything bad about DPO? It sounds almost too good to be true.
Well, some tasks didn't see as much improvement,
Okay,
but even then, performance was never worse than the first training stage.
gotcha.
So it's like a win-win. You're either improving or at least staying the same.
Right, because there are probably some things that AI just can't understand as well as humans. But I'm curious, the paper mentions another step in reward modeling.
Yeah.
What is that all about?
So reward modeling is like giving the AI a way to know it's doing a good job,
Okay, that makes sense.
like a sense of accomplishment.
How does that even work?
Think about teaching a dog a new trick.
Okay.
You give them a treat when they do it right.
Yeah, and maybe a little no when they don't.
Exactly.
Classic positive reinforcement.
Yeah, and it's the same idea for the AI.
So they're giving it like digital treats.
Kind of.
Hmm.
In reward modeling, you train a separate model
Okay.
that learns to predict which answers humans will find rewarding.
Interesting.
So it's like having another AI that's constantly giving feedback to the main AI.
Oh, wow. That's pretty cool. And I'm guessing that the learning rate and batch size stuff came into play here too?
You bet. They found that those higher ratios, the ones that were really good for the reasoning tasks,
Yeah.
they were crucial for reward modeling too.
So it really matters how the AI learns right from the beginning.
Yeah, exactly.
But how much better did the models with the higher ratios actually do?
Well, the difference was even bigger during this reward modeling stage.
Really?
Yeah, the higher ratio models were way better at predicting which answers would get rewards.
Wow. It's like they unlocked some hidden potential just by finding the right way to teach them.
Yeah, it's pretty cool.
Okay, so we've gone through like 3 steps now.
Yes.
This supervised fine-tuning, DPO,
Yeah,
and now this reward modeling.
right.
So is SmolTulu finally ready to like go out into the world and impress everybody?
Almost. They actually tried one more thing called reinforcement learning with verifiable rewards, or RLVR.
RLVR. Okay, you've got my attention.
So this RLVR takes things a step further.
Okay.
It actually uses the predictions from the reward modeling to help the AI learn.
Oh, so it's like the AI is learning how to learn.
Yeah, it's constantly improving its performance.
That's incredible. But there's a patch, right?
Well, this RLVR stage needs a lot of computing power.
Ah, I see. So even SmolTulu needs a break sometimes.
Yeah, I guess so. But even though they haven't finished exploring RLVR, the early results were really promising.
So we have this amazing small model, and it might be able to learn in even more complex ways.
Yeah.
But the research is still ongoing.
Yes.
Wow, this is incredible. I can't wait to see what they find out next.
Me too.
I am still trying to wrap my head around everything we've talked about today.
Yeah, it's a lot.
This feels like one of those deep dives that totally changes how I think about AI.
I agree.
It's not just about using a ton of computing power anymore.
Right.
It's about understanding how these models learn and teaching them in the best way possible.
Exactly.
Okay, let's just take a minute to recap all of this amazing science before we wrap up.
Okay.
Is there anything else you want to highlight about SmolTulu or the research in general?
You know what I think is the most fascinating?
What's that?
This research isn't just about making small models better.
Okay.
It's about rethinking how we approach AI.
Ooh, I like that.
Like for years, we've just been trying to build bigger and bigger models.
Right, just throw more computing power at it.
Yeah. But this study suggests there's a better way.
The small but mighty way.
Exactly. If we focus on the learning process itself, we can get great results with smaller models.
I see.
And that's a big deal, especially for people who don't have a lot of resources.
So it's about making AI more accessible to everybody.
Exactly. And just imagine the potential.
Yeah.
What if we had personalized AI tutors that can teach you based on how you learn best?
Wow.
Or AI assistants that are small enough to run on your phone and give you information in real time.
This is mind-blowing. It feels like we're entering a whole new era of AI.
It really does.
One that's more personalized, more efficient, and more focused on humans.
It's an exciting time to be working on AI, that's for sure.
Absolutely. Okay, so before we get too carried away dreaming about the future of AI, let's bring it back to SmolTulu.
Okay?
What are the key takeaways from all of this?
So here's what I think is most important.
Okay.
First, size isn't everything. We can get great performance with smaller models if we teach them the right way.
Awesome.
Second, the relationship between learning rate and batch size is super important.
Got it.
It's not one size fits all.
Uh-huh.
We need to find the sweet spot for each task.
Makes sense.
And third, this is just the beginning.
Oh, of course.
There's so much more to learn about how AI learns.
Yeah, this is really just scratching the surface.
Exactly.
Well, I always like to leave our listeners with something to think about, a
Yeah.
question to spark their curiosity.
I like that.
What's yours today?
Okay, so if different AI models learn in different ways,
Yeah.
do we need to change how we test them?
Oh, interesting.
Because the way we do it now might favor certain types of learning.
That's a good point.
Maybe we need new tests that are more inclusive and recognize all the different ways that AI can learn.
Whoa, that's a really great question. It makes us think about not just what AI can do, but how it learns
Exactly.
and how we can help it grow in a way that's good and responsible.
That's-
Okay, lots to ponder there.
Definitely.
Well, it's been a pleasure diving into this with you.
Likewise.
And to all of you listening, thanks for joining us on this deep dive.
Yeah, thanks for listening.
Keep those brains curious, and we'll catch you on the next one.
See you then. Hashtag TTS, the Deep Dive episode 2024-12-16, part 2 of 3. It's like teaching it to have good taste.
Oh, yeah?
Making sure it doesn't just like spit out random stuff,
Uh-huh.
but things that we as humans actually like and find useful.
Yeah, like actually understanding what we're looking for.
Exactly. It's like you're saying, hey, SmolTulu,
You're right.
here's a bunch of different ways to do this task.
Uh-huh.
Which one do you think people would like best?
Okay.
And then it starts to learn from that.
So it learns what we prefer,
Yeah.
but how do they even measure that preference?
So they do this really interesting thing
Okay.
where they show the model 2 answers,
Okay.
one that's good
Mm-hmm.
and one that's not so good.
Okay.
And the AI has to figure out which one is better.
So like showing it examples. Yeah.
Exactly.
So it can pick up on the patterns of what we like.
Right. Like it's not about giving it a set of rules.
Right.
It's more like showing it what works and what doesn't.
It's like teaching someone how to be polite by showing them examples.
Exactly. And the really cool thing is
Yeah.
they found that this process actually made the results from the learning rate and batch size stuff even better.
Really?
Yeah. So like, remember how we talked about how those ratios were important?
Yeah.
Well, this DPO thing made those ideal ratios even more important.
So the model that learned with that higher ratio for reasoning,
Uh-huh.
it got even better at reasoning after this DPO training.
Exactly. It ended up getting a score of 67.7%
Uh-huh.
on this test called IFEVL,
Okay.
which basically measures how well the AI can follow instructions.
Oh, wow. That's really impressive. I mean, if we can figure out how to teach these models in a way that's tailored to the task,
Yeah.
we could get some seriously good results.
Yeah, for sure.
Mm.
And the model that was trained with the lower ratio, it kept doing well on those pattern recognition tasks too.
Okay.
It scored 57.1% on ARC.
So it sounds like that initial training phase
Yeah.
was really important for setting them up for success.
It's like it laid the foundation.
Right. And then this DPO training just helped them to really hone their skills.
Yeah, it's like they were able to specialize.
That's pretty amazing. But were there any downsides to this DPO process?
Well, it wasn't perfect.
Okay.
Some tasks didn't see as much improvement from it,
Okay.
but even for those tasks, the performance never got worse.
I see.
It was at least as good as it was after the first round of training.
So it's like at worst, it stays the same, and at best, it gets even better.
Exact.
Can't really complain about that.
Yeah, no kidding.
But the paper also mentions one more thing called reward modeling.
Oh, yeah.
What is that all about?
So reward modeling is basically about giving the AI a way to know when it's doing something right.
Okay.
Like, it needs to feel good when it gets things right.
Right, so it can learn from that.
Exactly. It's like giving it a sense of accomplishment.
Okay, I like that. But how does that actually work?
So think about it like this.
Okay.
You're teaching a dog a new trick,
Yeah.
and you give it a treat when it does it.
Right, like a little reward.
Yeah. And you might say no, or correct it if it messes up.
Classic positive reinforcement.
Exactly. And reward modeling is kind of like that for AI.
So they're giving it digital treats or something.
Yeah, kind of. So basically what they do is they train a whole separate model that learns how to predict what humans would consider a good answer.
So it's like having another AI
Yeah.
that's constantly giving feedback to the first AI.
Exactly.
That is really cool. And I bet those learning rate and batch size ratios came into play here too, didn't they?
You guessed it. Those higher ratios that were so good for reasoning, they were also really important for this reward modeling step.
So it seems like those initial learning choices really have a big impact.
Yeah, it really sets the stage for how the AI develops.
So how much better did those models with the higher ratios actually do during this reward modeling?
Well, the difference between the models was even more obvious in this stage.
Oh, wow.
The ones with those higher ratios were much better at figuring out which answers would get rewards.
So it's like they found the perfect recipe for success.
Exactly.
This is seriously cool stuff. Okay, so we've covered supervised fine-tuning.
Yeah.
We've talked about DPO.
Yep.
And now we've learned about this reward modeling.
That's right.
So is SmolTulu finally ready to go out into the world and show off its skills?
Almost. They actually did one more thing.
Oh, there's more.
Yeah, it's called reinforcement learning with verifiable rewards,
No.
or RLVR for short.
RLVR. Okay, I am all ears.
So this RLVR takes things even further.
Okay.
It actually uses those reward predictions from the last step to help the AI learn.
So it's like teaching the AI to learn from its own successes.
Exactly. It's like it has a coach that's constantly pushing it to be better.
That's amazing. But I'm guessing there's a catch, right?
Well, this RLVR thing takes a lot of computing power, even for a small model like SmolTulu.
Oh, I see. So even SmolTulu needs to take a break sometimes.
Yeah, even AI gets tired. But their early results with RLVR were promising.
So we have this incredible small model
Yeah.
that might be able to learn in even more complex ways.
It's pretty mind-blowing.
But the research is still ongoing.
It is.
I can't wait to see what they discover next.
Me too. That's what's so cool about research.
Yeah, there's always more to learn.
Exactly.
Okay, I am still processing everything we've talked about.
Yeah, me too.
This feels like one of those deep dives that changes how you think about a whole field.
Definitely.
Like AI isn't just about having the most powerful computers anymore.
Right.
It's about understanding how these models learn and finding the best way to teach them.
It's like we're cracking the code of AI learning.
Exactly. Okay, before we wrap up, is there anything else you want to highlight about SmolTulu or this research? Hashtag TTS The Deep Dive Episode 2024-12-16, Part 3 of 3.
I think what's really interesting is that this research isn't just about making those small models work better.
Oh.
It's really like rethinking how we think about AI in general.
Okay, I'm intrigued.
You know, for years, the focus has been on just building bigger and bigger models,
Yeah,
throwing more data and more computing power at the problem.
just brute forcing it.
Right. But this research suggests that maybe there's a better way.
A more elegant way.
Exactly. Like by really focusing on that learning process itself,
Uh-huh.
we can get some really amazing results even with these smaller models.
The small but mighty approach.
Yeah, exactly. And this could be huge, especially for people who don't have, tons of resources.
Right, it makes AI more accessible.
Exactly.
So it's like democratizing AI.
Yeah. And think about the possibilities.
Okay, I'm listening.
What if we had these AI tutors
Yeah.
that could actually teach you based on your own individual learning style?
Whoa, that would be amazing.
Right. Or think about AI assistants that are so small and efficient that they can run right on your phone
Oh, wow.
and give you real-time information.
That's mind-blowing. It feels like we're on the edge of a whole new era of AI.
I know, right?
One that's more personalized, more efficient, and really more human-centered.
It's a really exciting time to be working in this field.
Absolutely. Okay, so before we get too caught up in all these amazing possibilities,
Yeah.
let's bring it back to SmolTulu for a minute.
Okay.
What are the big takeaways from this research?
So I think there are three main things to remember.
Okay, I'm ready.
First, size isn't everything.
Okay.
We can get incredible performance from these smaller models if we just teach them the right way.
Right, finding that optimal learning process.
Exactly. Second, that relationship between learning rate and batch size.
Yeah,
It's really important.
got it.
We need to find that sweet spot for every task and model.
Makes sense.
And third, this is really just the beginning.
Oh, for sure.
There's still so much more to learn about how AI learns.
It feels like we've just opened the door to a whole new world.
I know, it's fascinating.
Well, I always like to leave our listeners with something to think about,
Oh, yeah.
some kind of question to keep their minds going.
I like that.
So what's your question for today?
Okay, so if these different models have different learning styles,
Yeah.
doesn't that mean we need to rethink how we test them?
Ooh, that's a good point.
Like, our current tests might favor certain learning styles over others.
Right.
So maybe we need to develop new tests that are more inclusive
Yeah,
and recognize all the different ways that AI can learn.
that's a fantastic question. It really challenges us to think about not just what AI can do, but how it learns
Exactly.
and how we can help it to develop in a responsible way.
That's what it's all about.
Well, it's been a pleasure exploring all of this with you.
Likewise.
And to everyone listening, thank you so much for joining us on this deep dive into the world of small language models.
Thanks for tuning in.
Keep those brains curious, and we'll catch you on the next one.
See ya.